Like, we've been doing this stuff with my Algebra 2 class, very, very similar to what we're going to do today. There's a little bit more to it, but not a whole lot. And for some reason, when we start, I need to stay closer up here. Sorry, Tad. When we start to add and subtract fractions or these rational expressions, like that x's involved and stuff, we forget about all of our fraction rules. Like, we forget that we need common denominators. We forget all this kind of stuff. That we need to multiply top and bottom by the same thing. So if we can just remember that even the fractions that we're looking at today, even the rational expressions like this that we're looking at today, that these same fractional rules apply, then we're going to be a step ahead of, well, my Algebra 2 students. That's pretty good. But they have a test today, so hopefully they figured it out by now. Dang it, that's not right. We're adding and subtracting rational expressions. Adding and subtracting. The way that we're going to look at these is very similar to yesterday. I've got some examples written down. So if you want to copy these examples down with me, I think that'd be great. Also, your homework is going to be very similar to problems like this. So if we start with this first example, before we can add, we need to make sure, like always, that we have common denominators. In this case, they already give us common denominators, right? They're both 2x. So we can just add right away. Across the top, we have 5 plus 12. 5 plus 7 gives us 12. And what happens with our denominator here? What is our denominator going to be? I shouldn't have chose 12. But what is our denominator in this one? It's 12. So, like I said, our same fraction rules apply, but for some, and Amari, I'm really glad he said 4x, because that's exactly what we think, that all of a sudden we have these x's involved and our regular adding, addition, fraction rules don't apply. You know what I mean? So that's exactly where people go with it, but we need to remember our denominator doesn't change when we are adding fractions. So good, no big deal. Second one. We have a common denominator already, y plus 4 and y plus 4. So y plus 4 stays our denominator. Now we have 3y minus, now technically this would need to be in parentheses, right? But we can actually just do it before. Back up. We have 3y minus y minus 8. So we would subtract these just like we would any other time. We would need to look like this, and we would need to distribute this negative to both terms here. Now let's see, we have 3y minus y gives us 2y plus 8 over y plus 4. Are we done? That was a trick question. I totally set you up there. Not done yet. What can we do here with this numerator? Anything? What? Yeah, we can factor out a 2. Now what can we do? I should have given myself more room. Now what can we do? We have a y plus 4 up here and a y plus 4 here. You're left with just 2. Isn't that sweet how our lesson from, not yesterday, Wednesday, that's where we did this factoring stuff and cancel. How it comes back, even with adding and subtracting these things, Isn't that cool? That means you can't forget it because we're just going to keep doing it. Questions on that one? Do we see how I factored out of 2? We simplified and factored out of 2. Cancel, cancel. We're good. Let's see. How many of these? Why don't you guys go ahead and do number 1 and number 2 on your piece of paper? And after you guys get rolling on those, I'll start writing answers up here, and you can check what you've got. Give it just a minute to get started, and we can do number 3 together. Maybe, if we need to. Why don't you try number 3? Try all 3 of them. Make sure that your answer is in simplest form. Give me about 10 more seconds to get where I'm at with number 3. When they give us common denominators right away, just like in number 1 and number 2, then there's not a whole lot we need to do. We need to add across, simplify where we can, and we're good to go. Now with number 3, I'm going to try something. I forgot I could do this. Let's see how this works. Oh, you don't even see that's what I'm doing. Cool. Okay. With number 3, we can simplify the top to just be x plus 2, right? Now, we can factor the bottom, can't we? Yeah, we can. We have an x and an x. Let's see, we need a minus 2, so we know we have a plus and a minus. And then we also need a plus 1. So we'll have plus 2 minus 1. Now what can we do to simplify all the way? Abby, what can we do to simplify? Yeah, a little cancel, cancel. So we are left with 1 on top and x minus 1 on bottom. So just like we saw in one of those example problems, after we add things together and then simplify, we're not quite done yet, right? We need to make sure our answer is in simplest form, which we've been doing this whole time, right? We've been factoring things and crossing things out. So we just need to keep an eye on making sure that our answer is in simplest form, which sometimes it will be. Like here, it already was in simplest form. But once in a while, it will not be. Questions on any of those? Joe, how are we doing? Okay. Now, one thing, let's see, we probably won't do this last practice page. I want to talk through these together, look at 2 more examples, and then I'll get you the worksheet. When we look at our denominators, we need to be finding the least common denominator, right? You guys talked about that. Amari, when did you say you guys talked about fractions? 4th grade or something like that? You talked about least common denominator all the time, and we did that in the warm-up, right? Here it was 20, here it was 14, here it was 5, and 56. Now, we need to be able to find the least common denominator when we have x involved, or an x squared involved, or different things like that involved. And we need to be able to do that fairly quickly, otherwise these problems are going to take us a pretty long time. So what would be if, and we're not going to solve these problems, I just want to talk about what the least common denominator would be. What would be the least common denominator for 7g and 4g cubed? What would it be? If we just look at the whole numbers first, what number does it need to be? What is the least common multiple of 7 and 4? What? You're thinking factor. Multiples would be like 2, 4, 6, 8, 10, 12, 14. So if you think of multiples of 7, it's not 7, right? Because 4 can't go into 7. It's not 14. 4 can't go into 14. 21. Nope. How about 28? Yeah, 4 can go into 28. So we know that our whole number is going to be 28. Now, can we take away any g's from g cubed? Like, to get a common denominator, can we just say, all right, we're taking off a couple g's to make it even? No, we can't. So we need to get a we need to bring this g to be up to g cubed. So what would we need to? Well, so then our common, we don't even have to write what it would be. So then our common denominator would be 28g cubed. Now, what would we need to take it a step further? What would we need to multiply this fraction by to make it so we have this common denominator? To get 7 to 28, we need to multiply by 4, right? And to get our g up to g cubed, we need to multiply by g squared. Do we see that? Joe, you're not falling asleep on me, are you? I see those eyes. Those eyes are starting to... Whatever we do to the bottom, we also need to do to the top. Now, what do we need to do to this denominator, this 4g cubed, to get to our common denominator? We need to multiply 4 by what? 7. And what about that g cubed? Do we need to do anything? No, it already has all the g's it needs, right? It's all set. Now, this one I think we get, I mean, maybe we didn't get it right away, but I think this type of problem we pick up pretty quickly. The ones that might be not as natural for us right now are ones like this. We have an n and an n plus 1 as our denominator. What is our common denominator going to be? Well, this already has an n, and this has an n, but this plus 1 kind of gets in the way. We can't just take out that plus 1. In this example, right here, our common denominator was 20, right? So to get this 4 to 20, we multiplied by 5. We multiplied by our other denominator. To get 5 to 20, we multiplied by 4. We multiplied by our other denominator, right? You see that? We multiplied both denominators by each other. That gives us our common denominator. It's going to be the same idea with these. Our common denominator is going to be n times n plus 1. So we are multiplying these two together. To get this denominator over here to our common denominator, we would have n plus 1. We do that to the top and bottom. to get this other term, the second term, to have our common denominator, what does it need? What is it missing? Joe, what is it missing, that second term? If our common denominator is n times n plus 1, we already have the n plus 1. What do we need to multiply it by? Just the n. Yep. Do you see how it's the same as with our fractions? Like, same ideas, same concepts, but now it's just a little bit more complicated because we're multiplying by n plus 1 instead of just, 4, or instead of just 5. Do we see the similarities there? Abby, we see that? Okay. I don't want to go over that one right now. Let's look at this one. So in this form, x squared minus x minus 6, it's pretty difficult to see what term it's missing, right? Compared to the x times x minus 3. So what do you think we need to do before we can see what denominator we're missing? Factor. When we factor that out, we can see, they both have an x minus 3. I shouldn't be writing, I'll write a different color. They both have an x minus 3, so that's going to be a part of our common denominator. But this has an x plus 2, and this has an x. So how are we going to get these to have common denominators? What is it going to be? What? Yep, this is going to need, this one over here is going to need an x plus 2. What does this need? What does this denominator need? We have an x minus 3, x minus 3, x plus 2, but our first one still needs another x with it. Do we see that? There's a lot to that one. There won't be too many like this. But that's why we're spending 2 days on this lesson, because this common denominator thing can seem like a lot. So our common denominator is this whole thing, this whole mess is our common denominator. With this last one, even if we wouldn't totally think of that on our own, do we see where that's coming from? Lily, you seeing where that's coming from? Okay. Most of our problems will look like this one, and I know I didn't go over it, but will look like that one as well. Like this. Now this is not with common denominators. So what is our least common denominator going to be with these? Let's start with the number of it. We have an 8 and a 6. It's not going to be 8. 16, nope, 6 doesn't fit into 16. 24. So I'll just write over here, our common denominator is going to be 24, and then we have an x and an x squared. So it's going to be 24x squared. That's what we need to get both denominators to. Now we have 1 over 8x. So what do we need to multiply that by to get our common denominator? How do we get 8 up to 24? Multiply by what? 8 times 6? 3. How about to get from x to x squared? X times x, yep. Whatever we do to the top, we need to do to the bottom. That's why I'm writing it 3x over 3x. Now, if we look at 6x squared, how are we going to get that to 24x? What does it need to be multiplied by? 6 to get to 24 needs to be multiplied by 4. Now, what about our x's? Do we need to do anything? No, that's all set. Yeah, we already have x squared here, so we're all good with the x's. Now we need to multiply it and simplify. So 3x times 1. We know our denominator is 24x squared plus
Now we need to distribute this 4. So we'd have 4x minus 8 Do we have questions before I simplify this? Or do we see how I got to this point? Because simplifying this is, I think, something that we're more familiar with. This common denominators thing is unlike anything we've seen so far. Now that we have common denominators, we can add right across. 3x plus 4x minus 8 over 24, x squared. Now I'm going to move up because I'm running out of room. But we have 3x plus 4x would give us 7x minus 8 minus 24x squared. And there's nothing we can do to simplify, right? We cannot factor anything out of 7 and 8. There's only one x in this term here. And we can't just start canceling stuff because we're subtracting on top. Questions on that one? I think I've got one more example. Yep, one more example, and then you can have time, the rest of the time to work. X plus 3 over. First, we're going to need to factor the bottom here. Because when we look at x squared minus 8x plus 12, it's difficult to see what it's missing, like what denominator it's missing, compared to just x minus 6, right? It's not like we can see that it's off by an x or it's off by 4 or whatever it might be. So we need a factor. So we need it to be positive 12 but negative 8. Well, negative 8 is pretty large, so I think we're going to go minus and minus. And 6 and 2. Now, if we look at our denominators, we have an x minus 6 here and x minus 2, and here we have an x minus 6. So what is this second fraction? What is it missing to get our common denominator? X minus 2? I heard a whisper over here. A minus x? Well, we're looking at our full terms. We have a full x minus 6, we have a full x minus 6, and x minus 2, if we can multiply this by x minus 2 and x minus 2, we got the same denominator. So we would be good to go. So we'd multiply it by x minus 2 over x minus 2 to get our common denominator. Now we need to distribute the 2 on top. I'm going to run out of room again. Can I erase this? Or are you guys still writing that? Don't erase? You're not still writing? Okay. I'm distributing my negative. And then going to simplify. So we have an x and a negative 2x. That would leave me with negative x. And plus 3 plus 4, so plus 7. We can't do anything to simplify. We can't cancel anything else out. We're kind of stuck there. How are we doing? It's a lot of simplifying, right? If you don't keep your work straight and like line things up sequentially, there we go. And if you write all over the place, it's going to be really difficult to find mistakes if you missed a negative or whatever it might be. So this is where it's really important to be a little organized in our work.